One more example. A report tells us that in 2009 there were 870 great wolves in Idaho, but the population declined by 19% that year. Find an exponential model that gives them a wolf population W as a function of the time t in years since 2009. We will start with the equation. N is equal to P times A to the T power. Let's figure out, do we know P? Read the problem again. Yes, we know our initial value is 870 great wolves. Very soon you will know everything about animals. Wolves, buffalo, deer, foxes. So my P is equal to 870. Do we know A? You remember that A is a factor. There is a problem again. Do you see anywhere word factor here? No, there is not anything about factor. But there is one more number, 19%. If it's percent, what variable is this? 19% is the rate. So my R is 19%. And we remember by this time already that we have to change it to decimal right away. And we learned how to do it already. The next thing we have to figure out, what formula will we use? We have two choices. A is equal to 1 plus R, or A is equal to 1 minus R. How do we know what formula will we use? If we have growth factor, we use this formula. Let's write it down. And if we have decay factor, we will use this formula. Let's read the problem again. What do we see? We see the word, the population declined. How do you understand this word? Is population increasing or decreasing? Declined means decreasing. It means we have our decay factor. It means we have to use this formula. Do you see the logical thinking here? You have to follow the same logic. So this formula is irrelevant, or we have to use this formula. Let's do it. So my A is equal to 1 minus 0.19. We can calculate it right away. It will be 0.81 is our decay factor. Now we know the initial value. We know the factor. We're ready to write the formula down. N is equal to 870 times 0.81 to the T power. But remember, in these problems, they ask you to find the formula W. So let's rewrite the equation. W is equal to 870 times 0.81 to the power T. And now we have to answer the next question for this problem. How long must this rate of decline continue for the wolves' population reach 30? Okay, you understand that we found the equation, and you understand that we have to substitute 30 somewhere in this equation. Before you substitute this number, you have to think, what is W? W is a population of wolves. T is time. What is 30? 30 is population of wolves, so we have to substitute 30 instead of W. Let's do it. So it will be 30 is equal to 870, 0.81 to the t power. We have to solve this equation. This is an exponential equation because our variable t is an exponent. And to solve this equation, you have to have base to the exponent on one side. It's always a good idea to make everything visual. This part has to stay on one side. This number 870 has to go away. You always have to look for the operation here. It's multiplication. Opposite of multiplication is division. So you have to divide both sides by 870 and you have to divide by 870 here. I personally like fraction and I keep fractions. Many students do not like fractions, so they have to write it down a long number in this case. If you divide 30 by 870, the number will be 0.034486. You have to keep at least 6 decimal places, equal to 0.81 to the t power. I don't need this parenthesis anymore on this line. What do you see? We have base to the exponent on one side. So we are ready to use a logarithm to both sides. So it will be a logarithm of 0.034486 is equal to logarithm of 0.81 to the t power. Do you remember what will be the next step? We have to move t, the exponent t, in front of the logarithm. So it will be a logarithm of 0.034486 equal to t times a logarithm of 0.81. What we are going to do next? We want to have t by itself. In this case, we have to divide both sides by a logarithm of 0.81, so this will cancel out. And we have to divide by a logarithm of 0.81 on this side. Now we can type everything on the calculator, and our answer will be 15.98. You have to round your answer to 2 decimal places, years since 2009.